Sam, I'm going to tell you something right now that I think hopefully you already know, but maybe some of our listeners do not.
Okay.
You are pregnant.
Oh my. Yes. Thankfully, I did know that.
Yeah.
I think we're recording this when I'm 30. I think tomorrow I'm 31 weeks. So I should hope I know by now.
Yep. I think you should be well aware. But if not, good thing I'm here to remind you.
Good thing.
And of course, I am obligated to remind you that I was pregnant last year.
Yes.
And I remember thinking around this point, like, this would be so much easier if I could lay an egg. Like, instead of having this belly that was taking up all the space, instead of having heartburn, instead of having to, push a whole baby out, wouldn't it be nice to just have an egg that I could lay in a nest and I could go do my thing and the egg would do most of the work for me?
That actually sounds pretty amazing. I mean, there are parts of pregnancy that are so cool, especially from like a very nerdy science standpoint. But many days, I would absolutely love to just reproduce like a chicken.
Yeah. Unfortunately, or maybe fortunately, we are humans. And so we are a live-bearing species, which means that unlike chickens, we give birth to live young instead of laying an egg. So I decided to ask Oliver Griffith, an evolutionary biologist at Macquarie University, what's so great about being a live-bearing species?
That's a great question. It differs between species. In reptiles, where I think most of the research has been done, pregnancy and live birth seems to evolve in cold environments.
Oliver explained that if you move closer to the North and South poles, or if you move up mountains, you'll find more and more reptiles that are live-bearing species as opposed to egg-laying ones.
So laying eggs seems to be not a great strategy in cold environments. Live-bearing species, however, they can hold on to those eggs inside the mother, and then those mothers can go bask in the sun or manage the temperature of those developing embryos better. And so we get the evolution of live birth more frequently in these cold environments. And we think that's probably why it's evolving in there.
And Oliver noted that, of course, there are still species bearing live young in tropical environments. But it's just that for reptiles, cold environments seem to be where that capability evolves. And when I suggested, very professionally, that it seems great to be able to lay an egg, Oliver quickly dashed my hopes.
I mean, you still have to look after the egg and care for it in some ways. I think it's just as much work.
So fine, eggs are still hard work, and live birth has its perks. It's nice to not have to worry about where your fetus is and whether it's at the right temperature. But it's still incredibly complicated to meet the needs of a fetus. It's so complicated that we have to actually grow an entire organ to make it possible, the placenta. And the placenta is so important to reproduction that it's evolved more than 137 times in vertebrates. Welcome to Tiny Matters, a science podcast about the little things that have a big impact on our society, past and present. I'm Deboki Chakravarti, and I'm joined by my co-host, Sam Jones.
Today, we're talking about the placenta and how its development within the early weeks of pregnancy shape so much of what happens months later. We'll also be talking about what makes the human placenta so unique and how scientists are turning to evolution and computer models to see if we can better understand it.
The placenta is the only disposable organ in the human body.
That's Michelle Oyen, an associate professor of biomedical engineering at Wayne State University in Detroit.
So after you have sperm meets egg and you have the zygote and turns into an embryo, the first thing that happens is that the trophoblast cells, which are the placenta cells, start differentiating.
And the trophoblast cells, the cells that give rise to the placenta, show up early, just days after fertilization. Michelle told us that before you have any development of the embryo, you have to have the placenta because it basically acts as a whole bunch of different organs for the embryo and later fetus throughout development, providing nutrition and eliminating waste. But while it's doing that, the placenta also has to act as a barrier to make sure that blood from the fetus doesn't mix with blood from the mother. This is super important.
The blood does not mix because the mother and the fetus are different people. And that is a really important point. And I think this is one of those things that when people think of pregnancy, it's so weird that it ever works because you've got this genetically distinct fetus. But of course, the fetus has got half of its genetic material come from the mother. So we don't reject a fetus the way that you would reject an organ transplant. You have a liver transplant, you have to take anti-rejection medication. You don't reject a fetus. It's half your genetic material passed on, but half not. And so that blood mixing could be a huge problem because you can be different blood types. There's lots of different subtypes of different molecules that could be different because they're coming from the paternal genome.
Michelle told us that an embryo is typically ready to implant into the uterus around 8 days after fertilization. At this point, there are around 100 or so cells with a core made up of what will later become the fetus, surrounded by those trophoblast placental cells.
So it's those trophoblast cells that actually touch the mother's uterus, and that whole ball of cells essentially invades into the uterine wall. And this is my favorite part of this story. Cells from those trophoblasts actually take off, leave the embryo behind, and go into the wall of the uterus and start remodeling the mother's blood vessels because they're setting up that diffusion gradient where they can get the nutrients from the mother's blood supply. So it's like the first part that has to happen. I had a writing teacher who said something like, you have to set up the grocery store and stock the shelves before you can get to the point where you have the customer needing all of that nutrition.
I love that comparison. It makes me imagine the early pregnancy period as setting up shelves of breakfast cereal or something in the womb, but the shelves are made out of my tissue and arteries.
Right. And then an embryo shows up and raids the shelves, and the grocery store keeps expanding, which is important because the cells in the embryo and placenta keep dividing and differentiating through the first trimester. The embryo transitions into a fetus about 9 weeks after fertilization. And as pregnancy progresses into the second and third trimester, the focus shifts to growth. The placenta got its name in the 16th century in reference to a round cake made with layers of cheese and honey. So you've got this organ that kind of looks like a cake, and one side is up against the lining of the mother's uterus. On the other side, you've got the umbilical cord, leading from the placenta to the fetus. And within the placenta is the space where the exchange of oxygen and nutrients and everything else happens between the maternal blood and the fetal blood, which are separated by just a layer of trophoblast cells and the walls of the fetus's blood vessels.
The maternal blood is right up to the fetal trophoblast tissue. The maternal circulation is open at the placenta, which is another really weird thing about pregnancy. That you have normally your circulation is closed and it's always in blood vessels, but that remodeling that the trophoblast cells do in the mother's uterus opens up the maternal blood vessels such that her blood bathes the surface of the placenta.
So oxygen can simply diffuse across that barrier to reach the fetal blood, which also has a few tricks to make this process work better.
The oxygen affinity of fetal hemoglobin is higher than that of maternal hemoglobin. So there's actually like a little extra kick there.
So oxygen prefers to attach to the fetus's red blood cells, which is wild.
I know. And as you can imagine, the development of the placenta is really important for the development of the fetus. What I didn't appreciate until I talked to Michelle is how much the early weeks of the placenta set the stage for what can happen later on. One of the things Michelle studies is fetal growth restriction, which is when the fetus is small because the placenta isn't working very well.
And so you have something that doesn't show up until much later in the pregnancy where you start to see that the fetus is pretty low on the growth curve. And then that's often due to the fact that the placenta is small, but all of the seeds of destruction were laid in that first trimester when the trophoblast invasion was not as far into the mother's uterus as it would have to be to set up all of that exchange surface for later on.
Another pregnancy complication that might have its root in an insufficient trophoblast invasion is preeclampsia. Though unlike fetal growth restriction, which only affects the fetus, preeclampsia can be really dangerous to the mother as well.
Preeclampsia is, of course, most commonly thought of as elevated blood pressure in the mother. and sometimes additional symptoms with the kidneys and with the liver in the mother. But I kind of always think of it as your placenta is trying to kill you.
That's because, as Michelle reminded us, it's not the mother's placenta, it's the fetus's placenta.
And so it starts to interact with the mother's body in ways that affect the mother greatly.
Anecdotally, I had a preeclampsia scare in the week leading up to delivery, but luckily didn't have it. But I really remember that urgency my midwives felt around just the possibility that I could have preeclampsia and the fact that they had to keep tracking my blood pressure during labor to make sure that preeclampsia didn't start happening. It's estimated that preeclampsia occurs in 5 to 7% of pregnancies. And in the United States, it disproportionately affects Black women, who are estimated to be 60% more likely to develop preeclampsia than white women, which could be tied to a number of social factors. But we don't actually know much about why preeclampsia happens. In fact, that's true for a lot of pregnancy complications.
To me, this always highlights how poorly we understand human pregnancy. The fact that I can't answer your question better about exactly how the placenta contributes to all of these different things. The first trimester of pregnancy is a black box. We don't really have good ways of looking at it.
Michelle told us that some of the best reference materials we have to understand the placenta come from the Boyd collection, an archive from the 1950s and 1960s that was collected by a professor at the University of Cambridge named J.D. Boyd.
And it's a bunch of embryos, placentas, uteruses that were taken, like a hysterectomy was done when the person didn't know they were pregnant. That was before we had pee on a stick pregnancy tests. And so people would go and have a hysterectomy and they would be doing pathology looking at the uterus, and then they would find a little embryo. And that's the best source of information we have, because once people knew whether or not they were pregnant, we no longer have the ability to take out a uterus that has a tiny placenta and a tiny embryo embedded in that first trimester state.
And if we were talking about other parts of the body, like the heart or eyes or lungs, the answer for how to get more information would be obvious. We should look at other animals, in this case, the placentas of other animals, like mice. But it turns out that human placentas are kind of unique. For example, if we look at rodents, their ovaries continue making hormones throughout pregnancy. In humans, though, things shift during pregnancy so that the placenta becomes the main hormone producer.
And so you now have the placenta producing hormones that are affecting the mother's body, and they're not coming from her. They're coming from the fetal tissue. And so that's why this is such a complicated thing, that it's not just about the placenta itself. It's about this 3-body problem of the maternal side, the placenta in the middle, and then the fetal side.
Remember how close the maternal blood and fetal blood are in the human placenta, and how the maternal blood basically opens up to bathe the fetal blood across a thin barrier? Yep, that's very unique. If we look at animals like cows and sheep, we'll see a more separated system.
They have maternal circulation that's still closed. So the mother's blood is still in vessels, and then there's more tissue layers that it has to diffuse across to get to the fetal blood. And so, in fact, that's one of those things where we think it's because of how, humans evolved to need all of this nutrition for our big brains. And so what we've ended up with is a more invasive trophoblast and a smaller distance between the maternal blood and the fetal blood than in any other animal.
So cows and sheep have a very different relationship set up between the fetus and the mother.
It's a bit more of a cooperative environment in that the embryo can only get the resources that the mum is actually secreting to it. Whereas in humans, the embryo is a bit more in control because, it's got access to her blood supply. And so it can kind of decide how much it's taking up.
That's Oliver again. Oliver got his start in research through a love for reptiles, which might not sound like the obvious pathway to studying the placenta. But Oliver told us that while pregnancy and placentation evolved just once in mammals,
it's evolved many, many times in lizards and snakes, more than 100 independent origins of pregnancy and placentation. Because once you have an embryo inside the mum for an extended period of time and that embryo is developing, it needs to have an adequate supply of oxygen. It needs to be able to get rid of its carbon dioxide. and it needs at a minimum some nutrients like water and calcium, which it would normally get from the eggshell. So we get this structure forming that supports embryos in all of these instances where pregnancy has evolved.
So I just want to make sure I understand that. It's in any case where there's live birth, does that necessarily mean there is a placenta?
Yeah, there has to be some structure that's supporting it. And the kind of structure actually is different in different species. So in reptiles and mammals, it tends to be the uterus and some fetal membranes that are supporting that placenta as they come together. But in fishes, it can be crazy different structures.
My favorite example that Oliver told me about is the seahorse, where the placenta is basically skin tissue.
But it's not skin tissue of the mums, it's skin tissue of the fathers. Because in seahorses, the mums ovulate and release the eggs, and then the fathers collect those into a pouch in their abdomen and fertilize them as they're going into that pouch. And the placenta actually forms in the father's pouch tissue, which is just really modified skin tissue.
I don't know why it rocked my world so much to learn that male seahorses have placentas, but I'm still processing this fact.
Also, how nice would it be to not be the one in charge of growing the fetus start to finish?
I know, it sounds amazing. And when I was talking to Oliver about my wish to just be able to lay an egg, he mentioned the echidna colony he's been studying. Echidnas and platypuses are the only two surviving mammal species that lay eggs. And there are two things I have to say about echidnas. The first is that their young are called puggles, which is adorable.
Oh, so cute.
I know. And the second thing is that even though echidnas lay eggs, they might still have a placenta, at least based on observations from the 1800s and early 1900s.
These are the early explorers and early biologists in Australia, and found that there were eggs in the uterus that were quite small. And then they were much, much smaller than the eggs that were being laid by the mothers. And they kind of suggested that there must be some placenta-like structure, even though they're having a shell, that is nourishing those eggs after ovulation, but before they're being laid. And so this is something that I'm desperate to understand better. And that's why I've set up an echidna colony so that we can actually have access to some of those tissues to work out if what's being proposed is actually true. Because if there is an egg-laying animal that has a placenta, it's quite unique. And it would tell us something quite different is going on in mammals and how pregnancy and placentation evolved in them compared to other vertebrate lineages like reptiles.
When we talked to Oliver about what got him interested in studying the evolution of the placenta, one thing he mentioned that I hadn't thought about is that the placenta basically evolves every time you evolve pregnancy.
It is this unique situation where we have this repeated evolution of complexity, and it gives us an insight into how complex structures evolve in nature. And that can help us understand how other aspects of our complexity has evolved. It's a new organ. Most of our other organs evolved a really long time ago. The liver is at least 500 million years old, given the other vertebrates that have a liver. Other organs like the brain is probably more than 700 million years old. So understanding how they occurred is really hard because it happened so long ago and also usually only happened once. So we don't have any replication. But pregnancy and placentation happened really recently in some lineages, maybe in the last 100,000 years. And it's happened many times. So we've got like replication, which is really important in science. And we also have some transitional forms existing in nature today. So we kind of have all the things that would tick all the boxes to make it a good system to study the evolution of complexity.
For example, an important function of the placenta is to send nutrients from the mother to the fetus. And from his work comparing live-bearing and egg-bearing species, Oliver could see that the nutrient transporter molecules that make that possible are essentially repurposed through evolution from other parts of the organism.
The ones we looked at, they transport proteins from the gut into the blood. So we know they have a function there, but now they're being utilized in those placental structures to support nutrient transfer to the embryo. They're almost like recycling the genes in the genome to do this new function.
And even though human placentas are so unique, there's still a lot that other animals can teach us about our own pregnancies. For example, going back to the beginnings of the placenta, we have the implantation of the embryo into the wall of the uterus. But implantation often fails for reasons that are hard to know, especially because it happens so early on in pregnancy. And even with procedures like in vitro fertilization, we haven't gotten much better at implantation. If you want to learn more, we have an episode about the history and challenges of IVF research that we'll link to in our show notes.
An evolutionary perspective on how and why that implantation occurs the way it does gives us the ability to kind of work out how pregnancy was put together. And what we've found is that by taking this evolutionary approach, we've in the past misunderstood one part of that implantation process. And evolutionary comparisons have kind of told us that there are some aspects of this implantation thing that we thought were bad, but are actually good for us.
The thing that we thought was bad is inflammation, which is what our bodies usually do when we're hurt or sick. We'll get more blood flow to the injured area, and immune cells will show up to fight infections. And it turns out that inflammation is a big part of the pregnancy process as well.
It turns out inflammation does happen early on in pregnancy. And, researchers, particularly in IVF clinics, have kind of seen these inflammatory responses and thought, I know that inflammation is usually bad. And have they really tried to manage that? And so there are anti-inflammatory strategies that are still used in IVF clinics today because there is this kind of narrative that we have to protect the embryo from those potentially dangerous immunological things going on.
That seems logical, but Oliver and his colleagues wanted to see what role inflammation plays in our pregnancies and whether it really is something that can get in the way. Humans belong to a group of mammals called eutherian mammals, which have long pregnancies. So they compared the trajectory of eutherian pregnancies to those experienced by marsupial mammals like opossums, which have super short pregnancies, like on the order of 11 or 12 days. And they don't form their placenta until the end of pregnancy. Before that, the egg actually has a shell around it.
There is this shelled phase that happens that kind of persists throughout most of pregnancy. And then right before birth in most species, that shell is degraded and you get just a couple of days of placentation. And when we were looking at the molecular changes that occur in that placentation, we saw that there was this huge inflammatory response. And then the embryos were born. So it persisted for only a couple of days and then led to birth.
And the stage when they experience their inflammatory response is similar to when eutherian mammals get that direct interaction between the maternal and fetal tissues, which is funny because it means that inflammation shows up at the end of marsupial pregnancies, but the beginning of ours.
And what we think is happening is that this marsupial condition was ancestral. So the first live-bearing mammals, they had a short pregnancy and had that inflammatory process that led to birth. And then eutherian mammals have kept that inflammation around, probably because it's doing something functionally important for that setting up that maternal fetal environment. But then they're turning it off, and that's allowing for pregnancy to persist through the 9 months of a human pregnancy. But through comparing humans and marsupials, we've really been able to hone in on the fact that this inflammation is not something that we should be worried about in humans. In fact, probably it's something that is essential for setting up that healthy implantation environment.
There could be good reasons for this to happen, like maybe inflammation helps more blood flow to the area. But the role and potential advantages of inflammation are still mysterious.
So again, even though the human placenta is unique, there are ways to learn from other animals. And as scientists develop other techniques to study biology more broadly, they're also developing new ways to study the placenta. For example, Michelle's lab has been working on computer models of the placenta to make up for the lack of animal models. She's also been really fascinated by the interaction of the fetal cells with the uterus, developing a hydrogel that trophoblasts can move through in a lab setting so they can study the early stages of placentation.
And so we're looking at things like the patterns of how cells migrate through that hydrogel in response to a chemical gradient of something that we know would be there in pregnancy. That's all kind of trying to go towards a hypothesis of what is it that causes the trophoblast invasion to not be sufficient in fetal growth restriction or in preeclampsia. What's stopping it?
Every year, people get pregnant and experience complications. And every year, those pregnancies are the black box that Michelle described earlier.
The most shocking thing about this is how little we know about all of it. It's so complicated. It's so crazy that it works. And it's so amazing that millions of births happen in this country every year and all over the world, and we don't understand it better.
Michelle told us she's always questioning how far behind pregnancy research is compared to other areas of medical research. But she thinks it's decades, to say the least.
I've gotten a little bit involved with policy work now and the bigger women's health picture. And especially from my perspective, just trying to convince more people all the time that more engineers should be working on these complex problems in women's health specifically. And I think it's just so far behind. And it leads to things that are very complex as a researcher, because you are trying to write research proposals and write papers about the things that you're learning. And if someone isn't familiar with the field, they might think that what you're doing is actually quite simple. And it's like, yes, but we don't know it yet about this. We, in order to start building these computational models, we needed to know the properties of the uterus tissue and of the placenta tissue, right? We had to measure those things because they were not very well known. Whereas if you look in the literature, there are tens of thousands of articles about the material properties of bone.
Yeah, I mean, if anything, it seems like placenta research is like, this is where you can get in on the early stages.
Which is why it's so exciting.
All right. Are we tiny show and telling?
We sure are.
Go for it.
Okay, I'm here to tell you about drunk fruit flies.
Oh.
So, yeah, fruit flies, they love yeast, and they like to eat yeast that comes off of rotting fruit. And so that means that they get plenty of alcohol in their system, which they process pretty fast because they also have very fast metabolisms.
Right. They also live for like 48 hours. So
I know.
Everything's quick.
And so they can spend like a good chunk of it drunk if they want to. Like, no regrets for these fruit flies.
Yeah. Easy to meet their fate with that one if they're just drunk for the 48 hours that they're alive. Okay.
Yeah. And it turns out that getting drunk might also be pretty important to their mating.
Whoa.
Yeah.
Alarming, but okay, tell me more.
Yeah. So researchers found that consuming methanol helps the fruit flies make more sex pheromones, which helps the males be more attractive to females. Though, as one of the researchers noted, quote, the success of drunken male humans with females is likely to be questionable.
Yeah.
Yeah.
I'm going to say that right now.
Yeah. You don't only got 48 hours to make a fool of yourself and to have regrets.
Yeah.
So to study this, the researchers use a system called a fly walk, where 15 fruit flies were kept in these individual glass tubes, and they were subjected to different smells, including methanol and ethanol. And scientists just watched how they responded. And they found that male fruit flies who hadn't mated yet were really into the alcohol, which is consistent from results from previous studies that have shown kind of a similar behavior, that these male fruit flies they seem to like some alcohol. They also found that consuming methanol made more pheromones for these male fruit flies. The trade-off, though, which is very important to note, is that too much methanol can kill the flies. So yeah.
Yeah. Fascinating. So interesting. I'm seriously judging those male fruit flies.
Shouldn't we all?
Okay, well, that was a very fun one. I'm going to take a kind of dark turn. I feel like I should have gone first.
Maybe. Well, too late now.
Yeah, it's too late. All right. So I want to tell you about a new study that just came out of MIT that found that in Bangladesh, which is a super populated coastal country bordered by India and Myanmar, what used to be once in a century storm tides caused by hurricanes could now be striking every decade or even more frequently by the end of this century. Yeah, I told you it was a dark turn. So I wanted to bring this up because, of course, globally we're seeing this shift But this is also a case where as Earth warms, the climate changes, this region of the world, the global south, some people would refer to it as is going to be hit the hardest.
Yeah.
And it's something that we really dove into in an episode that we published back in August of 2023, which it was episode 40. I can't believe it was that long ago. In some ways, it feels so long ago. In some ways, not at all.
Right.
But it was titled, We're Not All in This Together, How Colonialist Practices Are Shaping the Impact of Climate Change. So definitely go check that out. We really dive into many, many factors. We're not just talking about weather events. But anyhow, I think that's why this new study stuck out to me because I remember doing research for that episode and just being blown away by the inequity that exists for many reasons.
Yeah, and in that episode, we also talked about Pakistan and waterways and the relationship. Bangladesh at that time, early on in that history was considered, it was called East Pakistan. There's a lot that shaped it, but water was a big aspect of that conflict too.
Right. Yeah, absolutely. So it's very complicated. I'm giving the very simple science version, but there's a lot of societal factors. And that's why I'm go listen to episode 40 if you haven't already. It's really infrastructure driven by colonialism, driven by, So just going back to this study, first off, I had no idea that Bangladesh is so densely populated. 171 million people live in this country that is roughly this size.
It's one of the most densely populated countries, right?
Yeah.
Or I think the city has, Dhaka might be the most populated city, maybe?
I'm not 100% sure, but that would make sense to me because this country is the size of New York State. In New York State, you have 20 million people. In Bangladesh, you have 171 million. So this is already setting the scene for if there's an extreme event, it's very, very dangerous for a lot of people.
Yeah.
All right, so let's talk about this research. So the way that these researchers, in a very basic sense, there was a lot of modeling that I don't quite get. It's really detailed. But what they did was they created a model of simulated weather patterns from a hurricane. So then what they did was they scattered what they call hurricane seeds in different regions within this model and then ran it to observe which seeds would grow and make landfall. And of course, all of this is based on previous data and trends in data.
Yeah.
And in the end, what they did was they actually simulated tens of thousands of potential tropical cyclones, i.e. hurricanes, near Bangladesh, taking into account various future climate scenarios. So beginning with there's little change from today to a future where we've continued burning fossil fuels at the rate that we are doing it. And then what they did, which I do not understand computationally, is calculate these hypothetical storms' return periods. So the amount of time it would take for a particular type of storm to make landfall again. And so when we think about 100-year event storms or 100-year storms, these are powerful, super destructive ones. They create these extreme storm tides. And what they figured out is that with increased global warming, storms that previously were considered 100-year events could return every decade or less by not even the end of this century.
Yeah.
Which is just it's alarming. It's upsetting.
Right.
And so the lead author has a quote that I found really interesting. He said, quote, "This climate change story that is playing out in Bangladesh in a certain way will be playing out in a different way elsewhere. Maybe where you are, the story is about heat stress or amplifying droughts or wildfires. The peril is different, but the underlying catastrophe story is not that different." And I thought that was a very insightful, succinct quote about what is going on and what we're seeing. So sorry, this was a downer one.
No, but it's super important. Yeah. And really, it's both really interesting, how they did the research, but also, really important to think about and process.
Yeah.
I read this great book last year. It's focused on the US, but I think for anyone who's kind of interested in learning more about how climate change is already affecting communities and the way people live, there's this book, The Great Displacement by Jake Biddle, that talks a lot about how communities that, have existed for a long time in parts of the US are having to make big changes and kind of the policy choices that are affecting a lot of different choices that they're able to make in terms of where they live where they moved to, how that intersects with, issues of like housing in the US as well. It was a really great book. And I feel like this feels like kind of a piece with a lot of things that I learned from that, even if it's in a different part of the world.
Yeah, absolutely. We will link to that.
Well, thank you so much, Sam. And thanks for tuning in to this week's episode of Tiny Matters, a podcast brought to you by the American Chemical Society and produced by Multitude. This week's script was written by me and edited by Michael, David, and Sam, who is also our executive producer. It was fact-checked by Michelle Boucher. Our audio editor was Jeremy Barr. The Tiny Matters theme and episode sound design is by Michael Simonelli and the Charts and Leisure team.
Thanks so much to Oliver Griffith and Michelle Oyen for joining us. Go rate and review us wherever you listen. We really, really appreciate it. And we'll see you next time.